Start once again. And this time, yesterday, like what we discussed, same thing, contact forces, but the type this time, which type? Yeah, contact forces, but the type of tension. Okay, the tension in our head, the tension in our brain, everything it will discuss. Got or not? So now, yeah, what's the date today? Saturday, 23rd December, 2023. Are you able to get me or not? Okay, so almost we completed so many things yesterday. We discussed about even free fall, flying off, inclined plane, pseudo forces, including even the masses and all. These kind of categories we discussed in a much more great sense. We'll combine all those effects once again, and we'll come on to the conclusion of one of the most important topic, and that is contact forces, which we call it as a tension. Okay, so let me just have I'll just share this video and put it on my WhatsApp link. I don't know. Okay. Okay. So should we start this? Yes. So first of all, I'll ask you. I'll go through the basic definitions, digressions, and all. Okay. And then I'll move ahead. Is that clear or not? So okay. So let us just have a little bit of representation of what is going to be called as tension, isn't it? And then I'll move ahead. Okay. So look over here. Let's suppose now, right now we are not including friction, so I'll not write it many times. I'm just considering all the surfaces to be smooth. Okay. And then what I did, I just placed two blocks over here. Okay. One block. Then there is another block. Okay. Just for the representation, they are not going to do anything. Just for our understanding what we are doing, we are just bringing them together so that we can understand tension in a much more greater sense. So let us bring two blocks, connect them with a thread. Let us just connect them with a thread. Now this thread is denoted by one line, but here I'm representing by two. That means I'm just considering a thick thread. Are you able to get me or not? What kind of thread I have? Just a thick thread and nothing else than that. Yeah, all the threads whichever we are going to consider right now, all are almost going to be massless in nature. So whatever thread we are considering, they are massless in nature. Okay, when we'll include masses in the thread, I'll come on that. Definitely I'll just also include the condition of the particular cases of those threads which has masses. So here we are considering a massless thread. Are you able to get me or not? Means the thread does not has mass, but the particles are definitely present. Is that clear or not? So let us think of mass m1 and mass m2. Now what I did, I just tried to pull this mass m2 towards right. Got it or not? I just tried to provide some velocity. मतलब इस mass m2 को थोड़ी सी मैंने क्या provide कर दी, एक velocity provide कर दी right की तरफ. Are you able to get me or not? तो क्या होगा, पूरा का पूरा सिस्टम थोड़ा आगे बढ़ने लगेगा, है कि नहीं? लेकिन अगर सिस्टम आगे बढ़ रहा है तो हो क्या रहा है बेसिकली, अगर मान लो तुमने इसको इधर की ओर धक्का मारा, तो ये जो थ्रेड के अंदर जो पार्टिकल्स, जो भी पार्टिकल प्रेजेंट रहेंगे, वो भी तो राइट की तरफ खींचे जाएंगे ना. आर एबल टू गेट मी? तो जब राइट की तरफ खींचे जाएंगे तो होगा क्या, बेसिकली तुम्हें मालूम है कि अगर मान लो दो पार्टिकल्स को मैं ये मान लो इंटरनली दो पार्टिकल्स एक दूसरे के आमने सामने है ना, तो वो एक दूसरे से अटैच्ड रहेंगे. अब तुम सोचो जरा, अगर मान लो ये पार्टिकल को अगर मैंने राइट की ओर खींचने लगा, मैं क्या किया, इस पार्टिकल को, सेकंड पार्टिकल को, आई एम जस्ट ट्राइंग टू व्हाट आई डू, लेट्स सपोज दिस इज पार्टिकल ए and that is connected with particle B, and I'm trying to pull this particle B towards right by a force F. Is this clear or not? तो ये जो पार्टिकल है ये ट्राई करेगा ना कि अरे ये तो पार्टिकल को खींच रहा है, मैं तो इस पार्टिकल को उसको खींचने नहीं दूंगा, है कि नहीं? क्योंकि इंटरमोलिकुलर फोर्सेस इतनी ज्यादा होंगी कि वो पार्टिकल क्या सोचेगा कि अरे भाई राइट की तरफ शिफ्ट ही नहीं होना. आर एबल टू गेट मी और नॉट? यस. सो बेसिकली होगा क्या, बेसिकली इस बी को शिफ्ट नहीं कराने के लिए ए इसके ऊपर एक फोर्स लगाएगा, है ना? एंड उसी फोर्स का नाम होता है क्या, टेंशन. उस फोर्स का नाम क्या है? टेंशन. मतलब अगर मान लो, हाँ, हाँ, अपोजिट वाला फोर्स। बेसिकली अगर मैं इस मास m2 को पुल किया फोर्स F के साथ, तो ये जो पीछे की जो पार्टिकल है, ये जो मेरी पार्टिकल, वो क्या करेगी, इसको पीछे खींचने की कोशिश करेगी। क्या करेगी? पीछे खींचने की कोशिश करेगी बाय अ काइंड ऑफ फोर्स, रिपल्सिव फोर्स, जिसका नाम क्या होता है? टेंशन। आर यू एबल टू गेट मी और नॉट? इज दिस क्लियर? अब होगा क्या, अब तुम कुछ सोचो। अब ये ऐसा तो नहीं है कि बहुत सारे, अब पार्टिकल ए लगाया तो तुम्हें मालूम है हर फोर्स का एक इक्वल एंड अपोजिट रिएक्शन आएगा। तो पार्टिकल ए के ऊपर एक रिएक्शन जाएगा ना, सेम अमाउंट का, एंड दैट वंस अगेन विल बी गिवन बाय द सेम फोर्स व्हिच वी कॉल इट एज टेंशन। सो दैट इज व्हाई अब ये पूरी की पूरी ये जो सीरीज है टेंशन की, ये पीछे बढ़ते जाएगी अदर अदर पार्टिकल पे। एंड में क्या होगा, जो पार्टिकल इस मास m1 के साथ अटैच होगा, उसके ऊपर भी सेम एक इक्वल एंड अपोजिट अमाउंट का टेंशन टी लगेगा। आर यू एबल टू गेट मी और नॉट? व्हिच विल ट्राई टू पुल द m1 टुवर्ड्स राइट। इज दिस क्लियर और नॉट? तो ध्यान से देखो, तो टेंशन दोनों चीज में हेल्प करता है। ऐसा नहीं है कि टेंशन तुम्हें, जैसे नॉर्मल क्या होता था, नॉर्मल मोशन में भी हेल्प करता है, नॉर्मल रिपोज करने के केस में काम आ रहा है। आर एबल टू गेट मी नॉट? सो सेम थिंग द टेंशन इज वर्किंग। दिस टेंशन इज ट्राइंग टू डिक्रीज द वेलोसिटी ऑफ m2, while this tension is trying to increase the velocity of m2. Are you able to get me or not? But both of these tensions are of same nature. Nature is same. Nature is same. Magnitude is same. Magnitude is also same, but the direction is opposite. Are you able to get me or not? Is this clear or not? So that is why this tension, what this tension is trying to do, decrease the velocity, while this tension is trying to do what? Increase the velocity. Are you able to get me? But as they are getting cancelled out, both of them will move with a common acceleration or not. Is this clear or not? So what will happen ultimately, as both of these tensions are getting cancelled out, these both of the blocks starts to move towards right with a common acceleration, and I call this as a common. Are you able to get me? Is this clear or not? मेरी बातें समझ में आ रही है यार? And इसलिए इस टेंशन को, basically this tension was called, as it is following the nature of contact forces, so equal and opposite, same magnitude, but one will help, another one will not help. We started calling that tension is nothing but tension is a contact force. Are you able to get me or not? What we started calling as a tension, tension as a contact force. Is this clear or not? Are you able to get me? Is this clear? I didn't check. 1 minute. Is this clear? मजा आया? तो बेसिकली कभी भी टेंशन लगेगा दो ब्लॉक्स के बीच में, या फिर ऐसा मान लो एक ऐसे वर्टिकल वॉल में मान लेता हूँ, ठीक, और उसके साथ एक थ्रेड के साथ, विद वन थ्रेड आई अटैच अ ब्लॉक ऑफ मास m, राइट or not? So when I will have this block of mass m, once again, 1 minute, when I will apply some kind of force F to try to pull this mass towards right, what will happen? This point will try to oppose this force by applying an tension. This contact will apply a tension, and then for that equivalent, equal and opposite tension must be applied for the wall also or not. Are you able to get me on? To balance that net force, so that the net force on this thread becomes how much? Also zero. अगर थ्रेड पे नेट फोर्स जीरो हो जाएगा तभी तो कॉमन एक्सेलरेशन से जाएंगे ना। आर यू एबल टू गेट मी और नॉट? या बट द वॉल, but the, yeah, wall will definitely move, but still the tension, the tendency of the particle will be same or not? Wall will never ever move. Are you able to get me? Basically I'm talking about the common acceleration of this scenario. Is that clear or not? Okay, is that clear? ठीक, तो सिंपल सी बात देखो, मतलब अगर कभी भी बात करूं, तो जब भी फोर्स लगाऊंगा, तो जो ये वाली जो कांटेक्ट है ना, बेसिकली जो भी कांटेक्ट तुम पकड़ो, जैसे ये वाली जो कांटेक्ट हुई, ये वाली कांटेक्ट क्या करेगी? टेंशन टी अपोजिट डायरेक्शन में लगाएगी। सिमिलरली इसके लिए जो टेंशन लगेगा वो किधर लगेगा, फॉरवर्ड डायरेक्शन में, सो दैट द नेट फोर्स ऑन दिस होल थ्रेड बिकम्स हाउ मच, zero, so that the bodies, both of these movies, both of the dolls, yeah, move with a common acceleration, and the distance between the particle will never ever change. Are you able to get me or not? But the question arises that why is this happening? So basically, this concept of tension appears for two cases, such that tension appears for the situation such that length of the thread never changes. Yes, it is possible that when we consider elastic thread, the tension will appear over there also. But right now, what we are considering is that the length of the thread is not changing, and that is why the tension must get cancelled on the whole thread. Are you able to get me or not? यस, क्योंकि अगर 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 तुम ही सोचो, अगर पार्टिकल के बीच में डिस्टेंस, अगर अगर लेंथ चेंज हो गया, तो बेसिकली क्या होगा, टेंशन डिक्रीज हो जाएगा ना, वेरिएबल हो जाएगी। आर एबल टू गेट मी और नॉट? So with this concept of the tension that equal and opposite nature also, tension is going to be a kind of contact force. And third important point, that they will always be getting cancelled on the thread. Are you able to get me or not? Yes. So with this type, we'll move ahead and then we'll see the nature of this thread as we looked into the normals. So try to understand. Let us consider one particular case. Okay, so think of one case. Let us imagine that let's suppose there is a vertical wall. Okay, and with this vertical wall, I hang a block of mass in. Yeah. So if this mass M is hanging over here, then what is the tension in the thread? Definitely, this mass M is trying to pull this thread downwards or not. Yes. What will happen? This mass, yeah, mass M will try to pull this thread downwards by its weight mg, isn't it? So for this mg, this contact will apply an opposite reaction, which we call it as tension in the thread, and that will be balanced by the similar tension. Are you able to get me or not? So basically, the tension in this thread is equal to how much? Mg. Are you able to get me or not? In similar fashion, क्या क्या क्या? Considering the system is at equilibrium, correct. Our system is in equilibrium. This thread is neither getting stretched, neither nothing is happening with the thread, got it or not? And the thread is also massless. Okay, now let us once again hang two blocks this time. ठीक है, दो ब्लॉक लगा दिया इस बार, है ना? ऐसे ही अपन करते जाएंगे, धीरे धीरे पहले सीखते जाएंगे कि कैसे ड्रॉ करते हैं, फिर अपन आगे बढ़ेंगे। मान लो इसकी वेट m2 हो गई और इसकी वेट कितनी हो गई, सॉरी मास कितनी हो गई, m1। नाउ कैन यू टेल मी द टेंशन इन द थ्रेड्स? Yeah. Okay. Now, how to identify? So first, I'll tell you one thing. I'll tell you one technique to identify. Now, as you see the blocks, if you look over here, the threads, the number of threads are how many? This is first thread, and since there is a breaking, so there is a second thread also. Correct. So how many threads are there? Two. So how many tensions? Two tensions. So remember the number of threads, the number of tensions will be there. Okay. Yeah. So now you tell me. It will be T1 and T2. Can I consider that a weight T2 is equal to M2G? Yes, correct. So basically, correct, totally correct. So here it will be M2G, isn't it? And for that there will be a reaction, I call it as T2, isn't it? And for that equal and opposite reaction T2, for that M1G will be downwards, and then T1 T1 will be upwards or now since the system is in equilibrium, I can write T2 is equal to how much? M2 into gravity Z and T1 is plus. Yeah, so this becomes how much? M2 plus GM1 plus M2. Are you able to get me or not? Now think of one more case. Let us bring one more case over here itself and consider that one. मतलब मान लेते हैं कि इसको तीन ब्लॉक नहीं, तीन ब्लॉक तो अब आसान हो जाएगा ना। मान लो इसी इसी पूरे थ्रेड सिस्टम को कहाँ लगा दिया, लिफ्ट के अंदर लगा दिया, कहाँ लगा दिया, once again lift, isn't it? So our case is revolves around lift and all those kind of things. I'll make you pioneer in this. So let us consider that the lift is first going upwards with acceleration a naught, then find the tension in the thread. And then again you have m into a naught plus means the tension should increase or decrease. It should increase. Why? Because you know that whenever okay, first identify, let us identify first, lift is a accelerating frame or non-accelerating. Tell me. Lift is accelerating, isn't it? Yes, so here over here the lift is which kind of frame? Accelerating frame. But basically those accelerating frame I can also write it as a non-inertial frame, isn't it? Whenever there is a non-inertial frame, what we have to do, if this is the weight, bolo. Yes. So the mass in that non-inertial frame will feel an pseudo force, but that pseudo force will be present in which direction? Opposite to the direction of accelerating frame. So this will be m into a naught. Are you able to get me on mass into the frame acceleration? Is that clear? And for that there will be tension T. So ये तो आसान हो गया ना? T is equal to how much? M G plus a naught if the system is in equilibrium. Are you able to get me or not? Yes, so once again, this becomes which kind of system? Non-inertial system. Okay, now consider the second case when the lift is going downwards. Yeah, so you have to take into first consideration of mg now. So the pseudo force as the lift is going downwards, the pseudo force will be upwards, which will be m a naught, isn't it? The tension T in the upward direction. So T is equal to once again how much? Mg minus, sorry, 1 minute. This will be how much? Mg minus N0. Are you able to get me or not? Is that clear? So here basically if the lift goes downwards, tension decreases. And here the tension increases. Are you able to get me? So two kinds of tensions appears for the equilibrium cases. One tension decreases and another tension increases. Are you able to get me? Understood? मजा आया? ऐसे ऐसे लगता नहीं कि मेरे को क्लासेस में पढ़ाते होंगे, है ना? एकदम नहीं। हाँ 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 हाँ। ऐसा नहीं होता है यार। मतलब मान लो अगर मैं आ गया क्लासेस में तो क्या होगा, क्लासेस पूरी बवाल हो जाएगी ना, है ना? अब लग रहा है फिजिक्स में कोई थोड़ी बहुत कॉन्फिडेंस आ रही है, नहीं आ रही? कंफर्म ना? बस यही चाहिए था। चलो, तो अब थोड़ा सा बॉडी को मूव कराने की स्टार्ट करें, है ना? अभी पुले वगैरह पे नहीं जाएंगे, अब थोड़ा सा हॉरिजॉन्टल केसेस पकड़ लेते हैं। हॉरिजॉन्टल केसेस में मैं बॉडी को मूव कराना स्टार्ट करूंगा, है ना? तो मान लो once again we have two block system just like yesterday's normal and all those kind of things, right or not? So let us just bring it over here and I connect these two blocks using a thread. Okay, now what I did, I tried to pull this whole system by a force F, not inclined perfectly with the horizontal but with a force F making angle theta with the horizontal. Okay. And then the question arises is that find the tension in the thread if this is a mass m1 and this is my mass m2. Okay. The blocks are moving. Where is the direction of force? Tell me first. Right. So where the blocks will go? Right. That's all. You have your answer. Since the surfaces are smooth, the blocks will go towards right. Okay. Over here, when I talk with the students, they tell me, "Sir, I'm teaching very, 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 very tough. Heard or not?" But when I talk to you guys, you feel like, "Wow, this is so nice." Basically, these are the only things which are going to come into NEET exams and all those kind of things, isn't it? So, okay, okay. Tell me, what is the tension? Okay, so we'll see that. Okay, so let's suppose as our normal convenience, हमें तो सबसे पहले तो फोर्स को रिजॉल्व करना होगा ना. इसकी अप्रोच क्या होगी? सबसे पहले फोर्स को क्या करेंगे? रिजॉल्व. देखो, अगर फोर्स लगाया तो ये तो पता है कि बॉडी एक्सेलरेट करेगी ही करेगी. आर एबल टू गेट मी और नॉट? अगर फ्रिक्शन नहीं है ना, तो एक्सेलरेट कैसे करेगा? हमें ये भी मालूम है कि थ्रेड की लेंथ चेंज नहीं होगी. आर एबल टू गेट मी और नॉट? सो acceleration will be a common acceleration. But that common acceleration will be towards right because the body is getting pulled towards right or not. So the question arises, if I resolve the force, this is F cos theta and this is F sin theta. Basically, अगर ध्यान से देखो तो if the acceleration is towards right, then which force is pulling it? F cos theta, isn't it? So this common acceleration must be equal to the pulling force F cos theta divided by the total mass which are moving m1 plus m2 or not. Totally. Is this clear or not? So you got your common acceleration. Now, if I look into the tension thing, so I know that this thing will be basically what we say opposed by the tension T for M2, isn't it? While the motion will be for this tension for this particular T, there will be equal and opposite reaction. Are you able to get me or not? So you have to clearly understand over here what is happening. That this tension T is trying to oppose the motion, while this tension T is trying to bring the motion in M1 or not. Yes. So if I look over here, then I can't say that F cos theta is responsible for the acceleration in M1. Basically, is this tension T which is responsible. If I cut the thread, then this tension T will disappear or not. So basically, what is actually pulling M1? It's not F cos theta, it's my tension T. Basically, are you able to get me or not? So this F cos theta, it's visible that it's pulling, but basically the force which is totally responsible is my not actually pulling it. Are you able to get me or not? So can I say, yeah, but it is pulling M2. That's why tension T is appearing. If you cut the thread, then this tension T will appear. No, no. So basically, which thing is pulling M1? Tension T is pulling my M1 with a common acceleration. How much? AC. So basically, tension T is equal to how much? M1 into F cos theta divided by M1 plus M2. Are you able to get me or not? And this is my contact force, or you can even say the tension present between M1 and M2. Are you able to get me or not? Is this clear? Can we have a can we have a little bit of much more depth analysis of this? Yep. So let us see uh, a much more depth analysis. Let us bring, your Imran sir is watching my YouTube channel, he's looking. Hi Imran sir, we all are here. Okay, thank you for this student who is saying that this physics is so fun. Yes, isn't it, Srishti? No, people tell that physics is hard, like if they study from me, that oh, I'm taking too much depth and all. But this depthness actually helps. They should understand later, isn't it? Okay, so let us connect. We have three masses this time, connected by threads, and then once again, okay, it's just a normal force is trying to pull it. Okay, and let us consider that this is mass m1, this is mass m2, and this is mass m3. Then find the tension in the threads. What is the approach? The first approach is, as remember always, in the case of threads, what will not change? The length of the threads will never ever change. So they are always going to move with a common acceleration. Always, if they are placed on a horizontal table. Are you able to get me or not? Okay, then do it. Pagal, pagal. Do it fast. You have 2 minutes. Should I write the common acceleration equation? Basically, this. Yeah, so basically this common acceleration will be the pulling force divided by how many masses are getting pulled this time? M1, then M2, and then M3. Are you able to get me or not? Now once again, how many threads are there? Two threads. So one will oppose, isn't it? Like this will be the direction of tensions, no? This will be T1, which will oppose F for M3. For that, equal and opposite reaction T1. Now, for this T1, you know that there will be, and okay, once again there will be a repulsive force, which I call it as T2, and that will be pulled by, that will be balanced by another T2. Are you able to get me or not? ठीक है ना? यही बनना चाहिए, इसी तरह का डायग्राम बनना चाहिए. अब बताओ, तो मैं लिख सकता हूँ. हाँ, no problem. Basically, it's not a problem. Ah, okay, correct. So, should I write? Should I change? Okay, so basically this. Okay, you are saying that you mark this as T2. Ah, no problem. So this is my T1. For that equal and opposite, and that is T2, and this is T2. Are you able to get me or not? This is your. Uh-huh. Okay. Then that's what I'm also doing. Okay. Ah, so you have drawn a wrong diagram then. Now look over here. Once again, I'll say. So for this mass, for this force, if M3 will be opposed by tension T1, are you able to get me or not? For that equal and opposite reaction by tension T1. Is that clear or not? So this is my first string. Are you able to get me? And then this is my second string. Are you able to get me? So for tension T1, as it is getting pulled towards right, there will be another repulsive force which is T2 and balanced by T2. So we can say that this tension T2 is trying to pull M1, so T2 must be equal to M1 into acceleration AC, means common acceleration. So what will be that? M1 F by M1 plus M2 plus. Is that clear or not? Yes. Now, once again, the third case, the third scenario, for mass M2, if I look, tension T1 is trying to pull, but tension T2 is trying to oppose the motion or not. So the equation will become what? The pulling force, which is my tension T1 minus the opposing force tension T2, and that should be equal to my mass M2 into its common acceleration AC. Are you able to get me or not? So basically, this implies that T1 is nothing but T2 plus mass into common acceleration AC. Are you able to get me or not? Yes. So this is my mass M2. Okay. So I can write the equation of T1, which is T2. T2 is basically we calculated, that is M1F divided by M1 plus M2 plus M3 plus this T M2 into common acceleration AC, that is once again F by M1 plus M2 plus M3. Add these and T1 becomes how much? M1 plus M2 into force F divided by M1 plus M2 plus M3. Is that clear or not? Totally. Is that clear? मजा आया? ठीक, चलो आगे बढ़े क्या? इसको लिख लो फिर अपन आगे बढ़े, क्रॉस वेरीफाई कर लो एक बार. Any kind, okay, any kind of doubt till now? No. Okay. Now, as we have went through this, now it's a time to bring some inclination in the planes, isn't it? Yeah. Once again, let us bring some inclination. All the types I'll discuss, no problem. Okay. So this time I have this whole system. Okay. Correct. Now I attach this block with a thread over here, and this inclination is of inclination theta, and the mass is over here m1 or m. Then the question is find the tension in the thread. Hmm. Yes, it is going to be M1G sine theta. You got the things now. How come your NLM was difficult? Within 3 lectures you got improved so much. This is AMG. Yeah, it's getting, this is called improvement, isn't it? Were you able to do all these kind of things previously? But not that much. But this is what is HC1. So this is AMG, and as you know, this will be once again theta. So this will be my AMG cos theta, and this side it will be how much? MG sine theta. Are you able to get me or not? For that means there is an equivalent. Now, as you know, from the center, the body will also create a normal over here, and yes, and then we'll have one more thing, that is, as the external force is present over here, there will be a tension T which will oppose this particular force. So we got the equation that both things are present over here. N is equal to mg cos theta, and then tension T is equal to mg sin theta. Are you able to get me or not? Yes. Now think of one case. Let us go to little bit of depth of all these kind of things. Should we go? Yes. So let us think of one case that we have. Uh, Let us think that we have a particular hanger over here. Okay. Okay. So this was my thread. Okay. This is my vertical wall from which I hanged this thread. Have you seen those ना, मीन्स घरों में ऐसे होते हैं ना, वो क्या बोलते हैं, ऐसे नहीं नहीं नहीं, मतलब वो जो छत पे लगाते हैं जिसमें अपन कपड़े वगैरह सुखा सकते हैं, तो वैसे ही. हाँ. हाँ, इंडिया में ऐसा रहता है ना. तो सो बेसिकली इंडिया में ऐसा ही चलता है ना. तो ध्यान से देख, अगर मान ली मैंने दो दीवारों के बीच में ऐसे एक थ्रेड लगा दी. हाँ, तो एक थ्रेड लगा दी. अब थ्रेड में ऐसा हुआ कि बेसिकली आई मेड मीन्स ऐसे आके एक कबूतर इसके ऊपर बैठ गया, एक चिड़िया आई. ठीक. ठीक. ऐसे आके चिड़िया मेरी चिड़िया थोड़ी खराब बनेगी है ना। एक चिड़िया मास एम की आगे यहाँ पे बैठ गई, अरे बोल गेट में कर रहा हूँ। यस। तो ध्यान से देखो तो ये क्या, जैसे ही चिड़िया बैठेगी ये थ्रेड बेंड होगा या नहीं होगा? कुछ इस तरह से ये बेंड हो जाएगा, आर एबल टू गेट मी और नॉट? यस। सो द क्वेश्चन इज कि as this thread gets bent, find the tension in the thread. If this thread gets bent by same angle theta with respect to horizontal from both the sides. बताओ क्या होगा? आसान क्वेश्चन है, सिंपल सी क्वेश्चन है। देखो, बनाओ मैं, एक मिनट देख लो इधर, सोचो जरा आप। तो जब ये टेंशन, जब ये थ्रेड बेंड होगा तो यहाँ पे नीचे एक फोर्स लग रही है ना, एम जी, लग रहा है। अगर ध्यान से देखा जाए तो इस सेंटर के ऊपर कितना लगा, एम जी। जैसे ही थ्रेड बेंड होगा तो टेंशन की डायरेक्शन डायरेक्शन कैसी हो जाएगी, अलोंग द टेंजेंट्स। टेंशन की डायरेक्शन कैसी, एंड सिमिलर अमाउंट होगा, है ना। तो इस टेंशन के क्या दो कंपोनेंट्स होंगे, एक हॉरिजॉन्टल एंड दूसरा कौन सा, वर्टिकल। आर यू एबल टू गेट मी और नॉट? आर यू एबल टू गेट मी? यस, डाउनवर्ड ही होगा। सो ध्यान से देखा जाए तो बेसिकली दिस इज व्हाट टी cos थीटा, this is what t cos theta, this must be how much, t sin theta, and this must be how much, t sin theta. So basically this sum of two forces t sin theta and t sin theta must be exactly equal to mg or not? Sorry, 2t sin, yes, 2t sin theta must be equal to how much, mg. Then only see the why I'm not resolving in the upward direction, because it will not give me the clear idea. Are you able to get me or not? So basically the, if I see the tensions, they will be, means if you look over there, for I'm drawing for the wall case, are you able to get me? So basically this for the wall 2t sin theta must be equal to mg or not? देख लो यहाँ पे। So basically अगर ध्यान से देखो तो t की वैल्यू आ कितनी रही है, mg by 2 sin theta. When the theta is very small, ठीक है, अगर ये थीटा स्मॉल हो गया तो t बराबर क्या आएगा, mg बाई 2 थीटा। आर यू एबल टू गेट मी और नॉट? व्हाई? बिकॉज माय थीटा इज स्मॉल दिस टाइम। आर यू एबल टू गेट मी और नॉट? मजा आया. Is that yes? It will be equal to how much? Mg by 2 theta. Are you able to get me? Okay, now let us combine this with one more case. Let us do one more case of this. Let us try to understand that there is a horizontal ground. Okay, and on top of it, a trolley is moving. What is going? Yes, a trolley is going with some kind of acceleration towards right. इस ट्रॉली के पास एक एक्सेलरेशन ए नॉट है. ठीक है, ये इसके चक्के होगा. और ये ट्रॉली जो है एक्सेलरेशन ए नॉट के साथ कहाँ जा रहा है? राइट साइड. बोल रहा है कि इफ आई हैंग अ पर्टिकुलर पेंडुलम of mass n over here. So then question is find the angle made with vertical after attaining equilibrium position and tension at that time. बताओ. Tell me. Will be there a backward force. So after देखो अगर इक्विलिब्रियम कंडीशन आएगा तो तुम्हें मालूम है. अच्छा पहले ये बताओ ट्रॉली एक्सेलरेटिंग या नॉन एक्सेलरेटिंग फ्रेम. तो इसके अंदर जो पार्टिकल होगा एग्जैक्ट हॉरिजॉन्टल डायरेक्शन में पीछे की ओर एक फोर्स फील करेगा क्या एम नॉट फील करेगा. तो कुछ देर बाद ये जो पेंडुलम होगी वो वर्टिकल के साथ ऐसे खड़ी हो जाएगी ना इक्विलिब्रियम कंडीशन पे. ऑसिलेट तो कर नहीं पाएगी. है कि नहीं? आर एबल टू गेट मी और नॉट? तो ध्यान से देखा जाए इस कंडीशन पे ये वर्टिकल के साथ एंगल थीटा बनाएगा या नहीं बनाएगा? इस डायरेक्शन में इसकी फोर्स एक होगी या नहीं होगी? फोर्स पहले से ही मालूम है वो कितनी है. एम नॉट. इसकी वेट लगेगी या नहीं लगेगी? और इसके साथ जैसे ही हाँ इसके साथ जैसे करना है ऑफ कोर्स करना है. देखते हैं पहले तो फोर्सेस ड्रॉ करते हैं. तो एम जी होगा और साथ में टेंशन टी रहेगा या नहीं रहेगा? तो these are all my forces which are going to act at equilibrium condition after time t. या तो अब ध्यान से देखो तुम मुझसे पूछा कि ये थीटा क्या है. तो थीटा तो ऐसे निकलेगा नहीं है ना. तो करूंगा क्या बेसिकली. आई नो दैट since if I can draw. Yes, so basically if I can do one thing that let us do one case of it, and that case is let us resolve this tension in its vertical and horizontal component. So this angle will also become theta. So this becomes how much? T cos theta, and this becomes how much? T sin theta. So can I basically write T cos theta is equal to how much? Mg, and T sin theta is equal to how much? Ma naught divided. Correct. So tan theta becomes how much? A naught by z or not? So theta is nothing but tan inverse A naught by, are you able to get me? Theta is equal to how much? Tan inverse A naught by G. Is that clear? Now I can do one more thing. I can take the square of both these and can I add it? So what this will become? T square cos square theta, T square sin square theta is equal to M square G square plus A naught square. Are you able to get me or not? If I take T square common, yeah, T is equal to nothing but M root under G square plus A naught whole square. Are you able to get me or not? Do this to find tension. Are you able to get me? आसान है ये सब. बस ये चीज सबसे टफेस्ट प्रॉब्लम मानी जाती है ना नीट में. तंग करते हैं ना ये सीडो फोर्सेस वाले. बस कुछ नहीं है, रिजॉल्व करते जाओ, है ना? है ना? बस आर एबल टू गेट मी और नॉट? अब थोड़ा सा हम इसको थोड़ा सा स्ट्रेच करें अच्छे टॉपिक पे. तो थोड़ा सा हम इसमें अब एक चीज ऐड करेंगे. अभी तक तो मतलब सिर्फ टेंशन पड़ा, अब इसमें थोड़ा सा एक कंटेंट ऐड करने वाले हैं जिसका नाम है पुली. क्या नाम है इसका? तो अब हम पढ़ने वाले हैं पुली के कॉन्सेप्ट. और पुली में सबसे पहली चीज मानेंगे, whatever is the condition is that we are ignoring the fact that what is the radius of the pulley. So let's suppose any pulley will be made in either of the disc or डिस्क से ही बनाएंगे, है कि नहीं? तो मान लो पुली डिस्क या सिलेंडर से बना सकते हैं. आर एबल टू गेट मी और नॉट? सो बेसिकली इफ इट हैज रेडियस r and mass m, both of these quantities are ignored for right now time being. The mass and radius of pulley is ignored for the time being. Are you able to get me or not? हम मास और टेंशन दोनों को क्या कर दे रहे हैं पहले? मास और रेडियस को दोनों को क्या कर रहे हैं? इग्नोर. आर यू एबल टू गेट मी? अब मान लो, अब अगर इस पुली के ऊपर किसी दोनों ऑब्जेक्ट मतलब दो तरफ अगर मैं थ्रेड ले लूं, ठीक है, तो इस थ्रेड को लगाऊंगा कैसे इस पुली के ऊपर? बेसिकली हमें इसके राउंड अबाउट लेना होगा. Yes. So that is why if you see one pulley, the tension from here to here or the thread that will be counted from here to here will be only one. How many threads I am going to count? Only one thread. Let's suppose if, even if I, yeah, let's suppose even if I apply two blocks over here, got it or not? Still at that time for these two masses, the tension or the threads will be counted as one. Is that clear? Okay. So we are going to combine this concept of pulley by one of the precious thing which we also call it as Atwood's machine, isn't it? Atwood's machine. Are you able to get me or not? We combine this over here and okay. Yeah, it is called by a name. Atwood, you have done that, but it has a name, so I brought it critically over here. Okay, so let us think that. Yeah, just it's just a name which it provides. There is nothing uh, concrete about that. Okay, so let us think that this is Atwood machine and this is attached with a vertical wall which is fixed over here. कैसा है अभी ये? Are you able to get me or not? अभी ये कैसा है? Fixed. अब मैं क्या कर रहा हूँ, इसके दोनों तरफ से दो थ्रेड ले रहा हूँ. सॉरी, एक ही थ्रेड ले रहा हूँ और आई अटैच टू ब्लॉक्स M1 and M2 over here. Are you able to get me or not? Is that clear? So there are two blocks which are attached, and the concept is if these two blocks are attached over here, then find the tension. क्या निकालना है इसमें? इस एडवर्ड्स मशीन में कुछ करना नहीं रहता है, बस फाइंड द टेंशन in the thread. Take if I consider M2 greater than M1. You think, you tell me. Okay, then. So tell me, what can be the equation? Uh-huh. Okay. So something like that you are getting. Okay, so I'll just see that. Now, M2 is heavier. So basically the weight of the block will be downwards, isn't it? And for that there will be a opposite repulsive force which we also call it as a tension in the upward direction. As the thread is 1, you know that M1 is of weight how much? M1g. And for that once again the tension T will be in which direction? Upward direction. So one of the biggest conclusion which you are going to draw is that if these blocks are attached over here, in case of pulley, the tension is always towards the pulley. कैसा रहेगा tension हरदम? If this, yeah, no, you have to write. We do not know still. Basically, the tension will be, yeah, you can say something like that. So this tensions will be same for the which kind of pulley system? Fixed pulley system. Which kind of pulley system? Fixed. And these tensions must be towards the pulley. Why I'm not writing away from the blocks? Because there are some cases where it will not appear away from the blocks. Okay. And I'm going to do that. Okay. Is that clear or not? So we have those tensions which are going to be always towards the pulley system and they are going to be same. So now as M2 is more, so this will try to accelerate and then as the length is not changing, so M1 must be pulled with the similar acceleration. Are you able to get me or not? Yes. So the equation becomes what? Since for M2, which force is basically accelerating force? M2G and tension T is a repulsive force. So the equation of M2 becomes what? The accelerating force minus opposing force is equal to my mass M2 into its acceleration. Are you able to get me or not? Similarly, if I look for M1, yeah, so here accelerating force becomes T, but the repulsing force becomes what? M1G. So equation becomes T minus M1G is equal to how much? M1 into acceleration A. That means what? I can combine these two equations. Can I do the combination of these two equations or not? Yes. So basically, if I combine this, yeah, basically, we are going to find everything. So tension will get cancelled, and I'll get M2G minus M1G is equal to M2 plus M1 into acceleration A, and we get the acceleration of these blocks, and that acceleration is nothing but M2 minus M1 into gravity G divided by M1 plus M2. Are you able to get me or not? Yes. Now, if you replace this acceleration in any of these equations, you will find that the tension is going to appear as twice m1 m2 divided by m1 plus m2 into gravity g. Are you able to get me or not? Is this clear? So basically, you can say that what is this? So why to think? Can we develop some trick regarding this? The answer is yes. What can be the trick? Basically, acceleration is what? Acceleration is pulling force minus opposing force divided by mass, isn't it? So look over here. For here, the two systems are pulled by the same force M to Z or not? Yes, and the tension will get cancelled. So which is our opposing force? M1G is my opposing force. Are you able to get me? See, this if I just imagine one case that this system was brought into a horizontal plane. Okay, means I remove this pulley and then this system will become a horizontal. This system will become horizontal or not? And that this makes this to be M2 and this makes, sorry, this makes to be M1. So looking at the equation, basically what we can say that this M2 is experiencing M2Z in forward direction or not. Look over here, pulley. This M2Z is working in which direction? Forward direction. While M1G is in directly backward direction or not. Are you able to get me? But they want to move with a common acceleration along the horizontal direction, isn't it? Yes. So basically, I can write it as what? A pulling force minus, as this will develop the same tension and these two tensions will get cancelled. So M2G minus M1G divided by M1 plus N2. So you can bring, if this pulley is smooth, you can bring the whole pulley system as a horizontal axis, on a horizontal axis. Are you able to get me or not? And then you can write the equation. So basically this becomes what? M2 minus M1 into gravity G divided by M1 plus M2. Is that clear or not? So that's your common acceleration. Are you able to get me or not? Now you know that tension T is equal to what? Tension T is trying to pull this M1 now. So tension T is equal to nothing but M1 into its common acceleration AC. No, you will get the, oh, sorry, 1 minute. You will have to write the equation. So here you can also look, you can write the equation for this M2G minus tension T is equal to M2 into common acceleration AC. And similarly for M1, if I want to write the equation, what I will get? Tension T minus M1G is equal to M1 into common acceleration AC. And you will get the answers. Same as T is equal to M1 plus M2. So basically you can say that acceleration is nothing but pulling force minus opposing force divided by total mass. Are you able to get me or not? Is that clear? Right. Totally right. Okay, so we can combine such things. We can combine such pulley in the, let's suppose there can be three block system, there can be many block system. We can combine all of these things, but the net concept remains same that whatever happens for the pulley, you have to remember that you between two blocks on the pulley, there is only one single thread, so that's why the tension remains same and the particles, each particle will feel the same tension, although the next thing is these tensions must be always towards the pulley system. Are you able to get me or not? Because look over here, as I just expanded that same case as a horizontal way, what happens? For this tension, there will be equal and opposite tension or not. So that is why in this pulley system also the tension T for this is upward and for this side is also it is basically upwards. Are you able to get me or not? Understood? Totally. What is the equation? Pulling force minus opposing force divided by total mass. Is that clear? Okay. So we are overing this whole thing tension till over here. We'll still do some more questions, include some more questions with the use of tension, with the use of normal, both this time. Okay. And before that, I'll complete basic one more type of pulley. And then I will like pulley on the left, pulley of three block system, three pulley system. Then I'll combine with the spring and then the normal tension spring concept. Are you able to get me or not? Tomorrow it will be the spring cases and those two different kinds of pulley system. Are you able to get me? Okay, and then I will bring the last the most important topic of this NLM before starting friction, and we call it as constrained motion. What we call it as motion, yes. And after constrained motion, 10 to 20 problems based upon all these concepts. Okay, and then friction. So almost around one lecture plus two lectures of one lectures of constraint, one, two, three, and extra wedge constraint. If we want to write two wedge constraints, so one extra more, one, two, three, four, and five lectures for this NLM, and one more lectures for one or two lectures for the friction. Are you able to get me or not? So almost we'll finish by six lectures. Is that clear? Okay. So basically this takes a long time because we are doing so many problems over here. Are you able to get me?